This video reviews bonds, covalent and ionic bonds.
Let's start by reviewing bonding. There are three main types of bonding: ionic, covalent, and metallic. Ionic bonding occurs between a metal and a nonmetal, in which the metal transfers electrons to the nonmetal to produce a positive metal cation and a negative nonmetal anion. These ions of opposite charge are attracted to each other to form a crystal structure consisting of alternating positive and negative ions. In covalent bonding, which occurs between nonmetals, the electrons are not transferred but only shared between the two atoms involved in the covalent bond. Here we have chlorine and bromine, neither of which have an overall charge. They share the electrons between them in a chlorine-bromine covalent bond. The third type of bonding, metallic bonding, occurs only between metals. Rather than transferring electrons as in ionic bonding, or sharing electrons as in covalent bonding, metallic bonding involves pooling of electrons. This means that the metal atoms come together and pool their electrons, or spread their electrons out throughout the whole metal domain. Instead of electrons being associated with the individual metal atoms, the electrons are free to move across the whole metallic structure. This is what gives metals their ability to conduct electricity. In each of these situations, the driving force behind bonding is the ability for the atoms involved to attain noble gas-like status. In essence, bonding allows atoms to feel like noble gases. In order to explain why some compounds are ionic and others are covalent, we use the concept of electronegativity. Electronegativity is a measure of how much an atom wants an electron. Atoms that want to gain electrons have a high electronegativity, such as the halogens on the right-hand side of the periodic table. Atoms that want to lose electrons have a low electronegativity, like the metals on the left-hand side of the periodic table. If we have a big difference in electronegativity between two atoms, we can form an ionic bond. If we have no difference between the electronegativity of the two atoms involved in forming a bond, we form a covalent compound. In an ionic compound, the electronegativity is big enough for a complete electron transfer to take place. In a covalent bond, there is no driving force between transfer of electrons, so we share the electrons evenly between the two atoms. The further to the right you get on the periodic table, the more atoms want electrons. Thus, atoms on the right of the periodic table have higher electronegativities. In many cases, the difference in electronegativity between two atoms is not big enough to form an ionic bond. However, the fact that a difference exists means that there will be an uneven sharing of electrons. When a small difference in electronegativity exists, we get a polar covalent bond, with one of the atoms involved in the bond pulling the electrons towards it due to its higher electronegativity. For example, in hydrogen fluoride, the fluorine has got a greater electronegativity and pulls electrons towards it. In this case, we have electrons shared unevenly, and we represent this using an arrow with a cross where the electrons came from and the arrowhead where the electrons are going to. This represents the distribution of electrons skewed towards the fluorine. We can also use the delta positive and delta negative signs. Delta simply means a small change in the overall charge, or a partial positive charge. The hydrogen is given some of its electron density to the fluorine, which means the fluorine has got a partial negative charge, leaving the hydrogen with a partial positive charge. Polar molecules are able to attract each other due to these delta positive and delta negative charges. The partial positive charge on one molecule is attracted to the partial negative charge on another molecule, and vice versa.